Hello everyone, I'm Dimitri Pinel, a research scientist at Sintef Energy Research in Trondheim, Norway. Today I'm going to give a very short presentation about GENeSYS-MOD, which is an energy system model, and the new version that we have developed in Julia. So just to give you a very short introduction to GENeSYS-MOD, it's an energy system model that was originally branched from osmosis in 2016 and then further developed through the work of several PhD students at TU Berlin. Some of them are present here today. And it's written in GAMS. It, like a lot of energy system models, it uses assumptions in terms of future energy demands, future cost projections, renewable potential, etc., policy, as well as carbon constraints in terms of cap, budget, or emission costs, or a combination to optimize transition pathways of the future energy system. So it can be used at different spatial resolution. Most often it is used at the European scale, but can be used also at country level scale, for example. So it is a model that is multi-energy carrier and multi-sectoral. You have a representation, of course, of the power sector, but also of hydrogen, heat, and over energy carrier and the technologies that do the conversions. You also have representation of heat in buildings, industrial heat at different temperature levels, and mobility, so transport of both goods and materials. So that's it for a very short introduction to the model. Then the main idea that we wanted to convey is the Julia version of the model that is new. So some years ago we decided to convert the model from GAMS to Julia, and that was motivated by the fact that we wanted to remove barriers to the use of the model. And GAMS is a really nice tool, and it's really efficient at what it does, creating optimization models, but it requires a license, and that's a barrier for wider use of the model. So we decided to convert the model and to use Julia. And originally we explored the use of Julia Jump as well as Python and Pyomo. We also briefly looked at Linopy, but it was still a very early stage of Linopy, so we did not look further into it. And we did not we choose Julia because the initial testing between Pyomo, Python, and Julia Jump showed that it was a bit more promising in Julia. We still had some issues in Python that we, in terms of model building speed, that we were able to resolve in Julia. So we focused on Julia. Just a few words on the conversion process that we use, and if you are planning to convert model, it's a process that we would recommend. So start with a very limited version of a model, remove as many constraints as possible to have the smallest version possible of a model. Don't focus too much on the input processing and the output processing, and then validate as you are progressing. The validation we did using a comparison of MPS files, which allows you to compare directly the coefficients in your matrices, and not have to compare results, and which can be difficult to find errors. So the main message is that, and the main takeaway that I want you to remember is that the model is now available on GitHub. So on this GitHub repository, you can find the GAMS version of the model as well, which had already open source code, but still had this barrier of using GAMS, and the new Julia version. There is also a data repository where you can browse through the data that we typically are using, as well as the sources and assumptions that we use. So the model is, we welcome everyone to try the model and give us feedback or contribute. There's still some work to be done to improve some of the performances and make more use of some of the Julia-specific, the Julia language specificities that can be used to have better performances. Thank you for your attention.